You could argue that we could write another add method that took a position, right? That said, I want to add at position 2. So sure, you can do that, right? That's actually easier. But addAtEnd, think about the fact that, remember we said we want to have this current node, right? This current node reference that is pointing here. The question is, if I want to add this new student, Lupe Lopez, if I want to add that new student at the end, where does current need to end up so that I can do that? Can I end up actually at the null value? That's the question. Because if I actually have current pointing to null, I then can't make this next reference point to something. If I dead end into the null, I can't actually do any operations anymore because I'm now past that node, right? I'm actually into the null territory. That means I can't put a dot. I can't actually do any more operations here. We would need to make sure that we end here is the point, right? We need to end up with C pointing here, not here, right? We need to make sure that current is pointing to the Chris Campos node, not to the null that's at the next of Chris's node. Does that make sense, Gary? So the question is, if we're not careful, we do what we did in size and we go too far and then we're stuck, right? So there are two ways to think of this, right? There are two ways to think of this. We'll come back to that. Actually, don't we do this here in a minute? Yeah. Yeah. So we have a slide here that talks about that. We have two ways to think about it. One way is a problem that I call the long arm approach, which is, Gary was sort of alluding to this in a minute, which says, you know, normally I go march, 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 and then I see, oops, I went too far. I can't take the chance of going too far. So what I'm going to do is I'm going to kind of long arm it. Instead of saying, is my next null, I'm going to say, is the next one null? So my arm is reaching out more, right? So I'm not checking my next to be null. I'm saying, is the next thing null over there, right? So I'm going to march differently because I'm looking ahead one bit, right? I'm looking ahead a node. That's what I call the long arm approach, right? Don't look at my next, look at the next links next. The other way to do it is with an approach called an inchworm, where you have your current pointer here, and then right behind it, you have a trailing or lagging pointer, such that every time you move current one, you move the lagging pointer one, but it's always pointing at the node behind you, right? So that way, if this thing runs off the end, it doesn't matter because you still got this lagging pointer to rely on. So then you can run current off the end like we did before, and you go, oh, yep, I know this is still okay, I can add now at this point. So you can either inchworm it, or that's called an inchworm approach, right? And it's called lag or trail or whatever you want to call that node, or you long arm it, right? Either way, perfectly valid. And in some cases, you may have reason to think either way. So if we want to make the long arm approach here, right, let's take the long arm approach and let's see if we can write addAtEnd. Okay, so public void addAtEnd, right? Still going to give me some data, and I'm going to want to add it at the end of the list instead of the beginning. So our first task is making sure we're going to again start similar that we did down here. In fact, I'm going to copy this. Right? You're always going to start this way. Okay. Now, this might be an interesting case. We might need to see whether this is going to blow up or be okay with an empty list. Right? I think this is going to blow up with an empty list, but let's see, right? Let's see. So how would we write this? Right? In this case, when we did size, we wrote a while loop, but we said, right? So we're going to do this still while current, but now the question is, I can't do this because that's going too far. So how about Gary's idea? I don't look at current, I look at current.next. I keep going, but I stop as soon as I see that my next pointer is null, right? March and march and march, but as soon as I see that my next pointer is null, I got to stop here. I can't go there to the next step. Okay. Does everyone see the idea here of stopping one short? The difference is in current.next not equal null versus current is not equal to null. Okay. And then I can go borrow some code from here. Of course, I'm going to make a new node in either case, but now I know that current is pointing to the last node, not the last node's null reference that's at next. Current is pointing to the last node. So what's my line of code that I need to do next to add this new node in the proper spot?
Can you just write current.next equals new node?
Just like that. Super simple if you know what. What's that? Already did that here. Yep. Make sense? Yes, we could construct the new node here, right? You could argue that maybe this is a wasted parameter, right? So yeah, wasted variable. So yeah, we could construct the new node and pass the data there. That's one good way to do it. And again, yeah. So yeah, I don't think that's a bad idea at all, right? That we simply do this thing, right? And then get rid of this new node variable. Why use a variable that's only used once, right? So I like that. Yes, thank you. Make sense? Now, does it work? I think it's not going to work, right? I think it's not going to work. I think that if we try to do addAtEnd here, my suspicion is, right? My suspicion is that's going to blow up. Let's see if it does. Boom. Cannot read field next because current is null. This is the typical error that you're going to run into, right? Typical error. So why is that? Because we tried to traverse, right? The very first thing we tried is if current.next is not equal to null, you can't evaluate next if current was null to begin with, if front was null, right? This evaluation, even the first time, caused it the problem, right? So now what do we have to do? So now I'm putting it back the way I had it because I think we might find that we might want to use it differently here, right? So now what do we have to do to special case front, which we very often have to do if we have an empty list, if front equals null. Else we gotta march, right? Else we gotta march. Okay, so if we're empty, if we have a new an empty list, how do we add it at the beginning?
Front equals new node.
Front equals new node, or we simply say addAt front because we already figured this all out, right? We could always do that, right? We could always just say, look, we already figured that out. But now that I've made the new node, right, I've gone to the trouble of making the new node. The other way to do it is to say front equals new node. There you go. Very typical in these to need that special case, right? Because front is not a node. Right? Front is a reference to a node, special case for an empty list, very, very typical in a lot of these methods. Okay? Makes sense? This code looks a little bit like gibberish when you first approach it. I know it looks odd, and if you're not keeping up, the best way to do it, go back and watch it again, watch the video again, but go and try to make one of these from scratch without looking at any of this. Take a piece of paper, draw some pictures, see if you can maybe start with just the node structure, but really you should be able to construct this whole thing, right? At least the simple ones like we've written, size and node. In fact, let's write one more because it's so easy. Let's just do that. There's added front, there's added. How do we clear? Public void clear. How do we clear the whole linked list?
Front equals null.
List is cleared, right? Don't have to set anything to null, because now that front is not pointing to the first thing, that is not loved. So it's going to be garbage collected, and its date is going to be garbage collected. And since nothing's pointing to the next node, it will be garbage collected, and on down the line, garbage collector takes it all away. We don't have to do anything else. That's convenient, right? That's convenient. All right. Any questions about that?
Can you add the front not equal null to your while loop, or you have to do it separately?
How would you add it to the while loop, I guess is the question.
I was just thinking like while current doesn't equal null and maybe front.
The problem is you can't put
Well,
it,
it's not. Oh, okay.
right?
Okay.
So in this case, yeah, I see what you mean though. Sometimes you might be able to gain some efficiency there. Sometimes you might be able to think of a way to do it, but I think in this case, it's really an if statement because we have to handle it a completely different way. And in fact, notice we don't even assign current because current is unhelpful, right? In this first case, current doesn't need to participate. So since that's really this versus that, I don't think that the while will be a good place to try to overload that, logic. Okay, but it's a good.
Well, think about the if statement. The if statement can be inside the while loop, like
Nope.
both the front. You check both the front and the current together.
Nope. This is going to blow up the first time you evaluate it.
Oh, okay, okay.
Right. So you could find a way to force it in, but I think the logic that you're going to write is uglier than the logic here. Right. You might be able to have a way to force it in, but then you're going to have if statements. Yeah, it's going to get ugly, I'm afraid. Right.
Couldn't you just do both? While current is null or current.next is null, or should that be and?
You
Checking
can't,
this null,
you can't type current dot anything without it blowing up.
No, first check if current equals null, or while current is not equal null, or current.next is not equal null.
I thought that too, actually, at first.
Yeah, are you saying do this? Oh, sorry. While front is not equal to null and current.next is not equal to null?
I think that should be an or, but yeah, basically.
But then you can't do this because current is going to blow up.
Why?
Because it's not, you can't do a dot when current might be null, right?
Yeah, that's why I'm saying, well, it shouldn't be front not equal to null, it should be current not equal to null. So you check both.
Yeah, then what are you going to do down here though? Because pointing current at something is not helpful. You got to point front to something, not current.
I don't understand the question.
Yeah.
You have to point front to something, not current?
With a new node, you have to change front. There's nothing you can do but change front at this point, right?
Yeah, current is set to front. So when you set,
that doesn't set front. Changing current doesn't change front.
I see. Okay.
Right? It doesn't change the reference. You can change what they point at. That's not changing front's reference to point to something new.
Yeah, got it.
So I think the answer is no, you can't do any other easy consolidation here. I think this is the code that really works here. Okay. Because really it's one of two separate roads here. Either front needs to be remapped, or you can do this